Good morning, students. Today's topic is angles and solid angles. Let's see first what is an angle. You take a point P and draw two straight lines. This is one and this is the other. Now I need to measure the angle between these two straight lines. Suppose this angle is theta. What shall I do? Very simple. Just draw a unit circle, that means circle with radius 1. What I prescribe is this arc length mn is the angle, but without the dimension of the arc length. Fine. How we do get it? See, we know the formula. Suppose if the radius is r and I say that r is equal to 1, as the circle is a unit circle, so we know this arc S, so arc S is equal to r times theta. Fine. So what is theta? Theta is arc S divided by r. Now see, the arc S has a dimension of length, has a dimension of length, but r is 1, so theta will be the arc length S, but there will be no dimension, as the dimension cancels on the denominator and the numerator. Fine. So this is something about angles. This is what is an angle. Now if we go to solid angles in the same flavor, what shall we do? Let's go to solid angles. So solid angles. What is a solid angle? First we need to know that. Suppose we need to take a point P. See, this angle is always about a point P. Angles are about a point, right? So in the same flavor, solid angles are also about some point. So about a point. Okay. Now take this point P. This is the point P about which you want to measure the solid angle. But solid angle will be of some area, right? Suppose you take an area like this, like this. Okay. Suppose you take an area like this and you join the edges of these area from point P. You need to join the edges. How do you join? Join this, join this, join this, and also you need to join that area. Suppose, okay, let me draw a solid line first, then we'll okay. So this is the thing which we have constructed. We have joined the edges. of this area. So let's name them. suppose this area is ABCD. Now in the previous case, means in the case of this angle, we have drawn a unit circle. In this case we need to draw a unit sphere, means sphere of radius 1. What shall we do? About this point we need to draw unit sphere. Like, just make the sphere a little bit smaller. No, never mind. So the radius of the sphere is 1. R equals to 1. So this is a unit sphere. Unit sphere. That means radius is 1. Okay. Now in the previous case, the line PM and PN cuts a portion of this circle. That's the arc, right? Here you will get 4 points on this, suppose this 4 points, or what shall I say, there was these 4 points, let me name them, where this PB cuts the sphere, PA cuts the sphere, PC cuts the sphere, and PD cuts the sphere. Suppose this W, this is X, this is Y, and this is Z. So what happens is there will be a little bit of area which is being cut by the unit sphere, right? The portion of an area which is cut by these lines. If we join all the lines, if we join all the edges, a portion of the sphere will be cut, right? Now if we say that is area, this area is S. Suppose area is S, this area S of the sphere, this area S of the unit sphere which is cut by joining the edges of ABCD with P is the solid angle subtended by the point P on ABCD. So what I did, I am just repeating it again, please follow. We take an area ABCD, right? This area, let me color it a little bit. Suppose this area ABCD. Now what we do is we join all the edges. Leave it. We join all the edges, right, and we get a portion of the area which is being cut out from this unit sphere, this area S, and this area S is the solid angle. Got it? This is the area AB. I am shading a little bit. Okay, never mind, this is the area, and I have joined all the edges. I have joined all the edges. The portion which is being cut out from this unit sphere is the solid angle. Now mathematically, how shall we place it? Let's get a mathematical form of the solid angle. We go to the next frame. I shall send you the note of this class. Let's go to the next frame. Suppose we have a point P, right? This is a point P, and suppose we draw two straight lines, or rather suppose let's take a small area. This is a very small area. I am saying small area means, suppose this area is dA, means in the language of calculus this is a very small area. Now if I join the edges of this area, what shall I get? A small cone like structure, but this surface, but the bottom of the cone is not perpendicular to the perpendicular bisector, means the central line of the cone or the symmetry axis of the cone. So what we need to do is, we need to take the angle. Let's draw the angle. Suppose from this point, if we draw a very straight line, this is one straight line. Now this area dA is a vector quantity or a scalar quantity? So see, area is a scalar quantity in 3 dimension. How? Let me explain it a little bit. Suppose this is an area, and if you take this area in a 2-dimensional plane, suppose this axis is the x-axis and this axis is the this former is the this is the x-axis and this is the y-axis. Suppose this is x and this is y, and this small circle is the area. Now if we traverse this area in an anti-clockwise fashion like this, and in the same fashion if we take a right-handed screw and rotate it, the tip of the screw will go in this direction. The tip of the screw gives the direction of the area vector. So the area vector will point from here to here. So it is perpendicular, so it is along the z-axis. So this is the area vector and this is the area scalar. Now so the area vector is perpendicular to the area. So area vector is perpendicular to the area. Okay. Now in this case of solid angle, so what will be the direction of this area? So direction of this area will be, you take the central point and it will draw up just a perpendicular line, and this is the direction of the area, and this will be dA vector. Fine. Now what's the angle between this straight line and this dA vector? This angle is theta. Now if I take a very small area which is be perpendicular to this line, suppose let's name then, suppose this line is PM. Suppose this line is PM. Now if we take a very small area, we take a very small area, this area, this to surface will make an angle also theta. Let me draw it, then you will understand. Suppose this is one this line lies on this initial, and this line also lies on this final area, which is perpendicular to this small area, right? So this will be also theta. Now in the same fashion, what we do is, if we draw a unit circle, unit sphere, the unit sphere, my prescription is, this area cut out by this unit sphere is the solid angle. This area is the solid angle. The radius of this unit sphere is 1. And see, if we are measuring the solid angle of an elemental area, so the solid angle will be also elemental, so this is denoted as d omega. Now if this slanting area is dA, so what will be this area? Let me color it with green a little bit, then you will understand. Let me color it with green, this green area. So this area will be dA cos theta. Fine, dA cos theta. Now think of similar triangles. What is how similar triangles are measured? Suppose you take a, sorry, just wait. Now suppose this is suppose A, B, C, D, E, and take a perpendicular line from E to this point, and say this point is as M and this point is N. Now BC is parallel to DE. Okay, so can't I say DE by BC is equal to AM by AN? Now in the same flavor, if this point, suppose this point is Q, here it is at a distance R, so PQ is equals to R. Can't we say that this area, what is this area? This is dA cos theta, right? Let me darken a little bit. So dA cos theta, right? So can't we say in the same flavor, dA cos theta by d omega is equal to, but here since it is case of, this is the case of area, so it will be R square by R square, right? Just see this. This is DE by BC is AM by AN, but here d omega cos theta, dA cos theta by d omega, where d omega is the solid angle, is R square by R square. Now capital R square is 1. So what is d omega? So d omega is dA cos theta by R square, as R is equals to 1. So this is the solid angle of an elemental area which is at a distance R about a point P, and this area has an angle theta with the perpendicular line or the straight line joining P and the area PQ. Got it? So we need this concept very much in case of electrostatics. We shall be using this. This is a mathematical tool. So that's why I taught you this. Thank you very much.